The Spectro-Photometer for the History of the Universe and ICE's Explorer, SPHEREx, is a planned 2-year mission that will survey the sky in optical as well as near-infrared light, which, though not visible to the human eye, serves as a powerful tool for answering cosmic questions. The SPHEREx mission will have some similarities with the James Webb Space Telescope. But the two observatories will take dramatically different approaches to studying the sky. For example, NASA's recently launched James Webb Space Telescope will target individual exoplanets, planets outside our solar system, measuring their size, temperature, weather patterns, and makeup. But do exoplanets, on average, form in environments that are conducive to life as we know it? With SPHEREx, scientists will measure the prevalence of life-sustaining materials like water that reside in icy dust grains in the galactic clouds from which new stars and their planetary systems are born. Astronomers believe the water in Earth's oceans, thought to be essential to life starting on Earth, originally came from such interstellar material. SPHEREx and Webb differ not only in their approach to studying the sky but in their physical parameters. Webb is the largest telescope to ever fly in space, with a 21.3-foot, 6.5-meter primary mirror to capture the highest resolution images of any space telescope in history. The observatory protects its sensitive instruments from the sun's blinding light with a sunshield that's as big as a tennis court. SPHEREx, on the other hand, has an 8-inch primary mirror and a sun shield that is just 10.5 feet, 3.2 meters across. But both observatories will collect infrared light, wavelengths outside the range that human eyes can detect. Infrared is sometimes called heat radiation because it is emitted by warm objects, which is why it's used in night vision equipment. The two telescopes will also both use a technique called spectroscopy to break infrared light into its individual wavelengths, or colors, just like a prism breaks sunlight into its component colors. Spectroscopy is what enables both SPHEREx and Webb to reveal what an object is made of, because individual chemical elements absorb and radiate specific wavelengths of light. Astronomers will use the mission to gather data on more than 300 million galaxies, as well as more than 100 million stars in our own Milky Way. SPHEREx will survey hundreds of millions of galaxies near and far, some so distant their light has taken 10 billion years to reach Earth. In the Milky Way, the mission will search for water and organic molecules essentials for life, as we know it in stellar nurseries, regions where stars are born from gas and dust, as well as disks around stars where new planets could be forming. Every 6 months, SPHEREx will survey the entire sky using technologies adapted from Earth satellites and interplanetary spacecraft. The mission will create a map of the entire sky in 96 different color bands, far exceeding the color resolution of previous all-sky maps. It also will identify targets for more detailed study by future missions, such as NASA's James Webb Space Telescope and Wide Field Infrared Survey Telescope.